Welcome to City and Guilds Math and English Lessons. I am Tamika Lodge Fenton. Let us look at some questions from the City and Guilds exam. Our first topic for the day is ratio. First question. A catering assistant mixes 4 parts of cordial and 12 parts of water. Express this as a ratio in its simplest form. Let's just look at some of the words that is in this question. What about cordial? Who knows what cordial is? Well, cordial is similar to what we have in Jamaica as syrup, but it's a more fruit-based and it's a little bit more concentrated. So they're mixing juice here. So they have 4 parts of cordial to 12 parts of water. How does that look represented as a ratio? So we have 4 to 12. Now, is that the simplest way we can write it? Clearly not. You can find a factor for both and write it in a simpler form. 4 is a factor of 4 and 12. 4 factored into 4 goes 1 time. 4 factored into 12 goes 3 times. So the ratio is a 1 to 3 ratio. That means, simply said, 1 part of cordial, 3 parts of water. Next question. So the chef allows 75 grams of rice per portion. Now, what if the chef had 5 kilograms of rice? How many portions of 75 grams can he get from this? What's the first thing you think about? Great. So the portion, the rice portion we refer to is in grams, and the portion that we're going to take the portion from, I should say, is in kilograms. So what I would do, or what I hope you would do, is to work it out so that you're working in 1 unit. So since we have grams in the smaller unit, let us convert the 5 kilograms to grams. Now you should know by now that 1,000 grams make 1 kilogram. So 5 kilogram is equal to 5,000 grams. Now, how many 75 grams can I get from 5,000 grams? Yes, this requires us to divide 5,000 by 75. What did you get? Yes, that's a unique number, isn't it? 66.666. Now, if you were looking at some previous lessons we have, there's a special name for this kind of number. It is a recurring decimal. Yes, but the question asked you, how many portions can he prepare from a 5 kilogram bag of rice? So the number of portion would be 66 portions. Okay, awesome, great job. Now let's look at another question. How long was that? Let us read it together. At the end of a 15K road race, the first runner crossed the finishing line at 7:52 a.m. The last runner crossed at 9:05 a.m. How long after the first runner did the last runner cross the finishing line? What are they asking you to do? Yes, they're asking to calculate the time that would have lapsed from the first runner crossing the finish line to the last runner. Now, how do we do this? Now, I'm going to go to the board just to help those who probably need a little bit more. So what we have 9:05 is the last time, and we have 7:52 for the first time. So we're going to subtract to see how much time have passed. So 5, that's 5 minutes, taken away 2, we get 3. Awesome. Now we have the 0 here to subtract that 5. We are going to have to regroup our hour. So this is our 9 hour, and we are going to take 1 of it. Now, how many minutes make an hour? That's the important question. Correct, 60. So if I were to regroup one of my hour, I would have to put it to 60 minutes. So 60, take away, this is actually 50, you'd have 10. Put back my there. So a take away 7 would give me 1 hour. So I'm saying from 7:52 to 9:05, 1 hour and 13 minutes would have elapsed. So it took the person 1 hour, 13 minutes. The last person came across. Next question. The table shows the weight of births of 90 babies born during May. So you have weights in kilogram and you have numbers of babies. What fraction of the babies weighed at least 2.6 kilogram at birth? Now you're going to look at your table and pick out the information. So we have 9 babies, number of babies, 9 weighing 2.3 kilogram. We have 8 babies, 2.4 kilogram. And you can continue and see that we have some baby weighing 3 kilogram, and that's 21 babies. So if you're looking at 2.6 kilogram, what number of babies correspond with that? 6. So out of the 90 babies, 6 out of the 90 babies would have had 2.6 kilogram. And that would be simplified as 1/15. Next question. What information do you see in this table? Let us look at what the table is saying first. This table shows how tornadoes are classified according to their wind speed measured in miles per hour. And you can see MPH is miles per hour. So we have tornado classification F0 to all the way to F5. The intensity wind speed, and you can see there's a range of the intensity wind speed. What is the question asking? Which tornado classification has an intensity wind speed of 146 miles per hour? So I'm not seeing 146 miles per hour anywhere there. But can I account for 146 miles per hour? Of course I can. If I look at F2, I see that the range is 113 all the way to 157. Therefore, 146 miles per hour would fall in my F2 category. Okay, and you see the little tornado there for those who, we don't have tornadoes in Jamaica. We have little, what we call whirlwind, but we've never really seen this here. So that's one for those who don't know. All right. So you have, which of the following sets of numbers contain all the factors of 16? What is a factor, guys? A factor is a number that can be divided into another number evenly without any remainder. So let's look at 16. What is the first factor of 16? Well, of course, I know you're going to say 1 because 1 is a factor of all numbers. Excellent. What about 2? Yes, we can get a certain number of 2's, or let's do it. So we can get 8 groups of 2's from 16. So that means 8 is also a factor. What about 4? Great, because 4 multiplied by 4, which is both of them are products, now give you a product of 16, I should say. Both factors give you a product of 16. So we're looking at 1, 2, 4, and 8 so far. And then, of course, 16 is a factor of itself because you can get one group of 16 from 16. So your answer here would have been option C. Now, let's look at this. Everyone's looking at the screen? What is that sign? Who knows what that symbol stands for? It is the square root of 81. So they're asking you to find the square root of 81. What the square root means? Perfect. If you said it is what number can multiply by itself to give me 81, you are right on track. So let us look and see. You can play around a little bit with your knowledge. So we know that 10 times 10 gives us 100. So we can't, the number will not be greater than 10 then. And then we can go a little bit lower. 8 times 8 is 64. So that's less than 81. So what is between there? Yes, 9 times 9 is 81. So the square root of 81 is 9. Now, next question. Standard form. What is 6,300 written in standard form? Okay, let us look. So what is standard form first thing? It is a way of writing very large or very small numbers easily or in a more compact way. Now, you might think standard form isn't that important to you today, but if you become a scientist one day and you have these very minute calculations to record, you may just realize that standard form is awesome. And if you have very large numbers to record, standard form will become very useful. Some places also call it scientific notation. So let's just look at 6,300 written in standard form. And that would be 6.3 multiplied by 1,000. That means 6.3 multiplied by 1,000 will give you 6,300. Now, you refer to it in powers of 10. So let's see how else we can write this. So let me correct myself. 6.3 multiplied by 1,000 is not yet standard form. It is how we're getting there. So it is a 6.3 multiplied by 6 to the third power, or what we say by 10 to the third power, or what we say 10 cubed is the standard form. Let us continue looking at some more questions. So this one says, what is 2.9 multiplied by 10 squared, written as an integer? So the first question I'm asking is, what is an integer? Do you remember? All right, let's see. An integer is a number that can be written without a fractional component. So that I'm giving you some examples of integers. So you have both positive and negative integers. 4, 2, negative 67, those are all examples of integer. But 3.24, a half, 2 and a half, those are not examples of integers. So we want to write 2.9 multiplied by 10 to the second power as an integer. So let us look what we're going to do. So 2.9 multiplied by 10 squared. 10 squared is the same as 100, so 2.9 multiplied by 100 gives us 209. So that is as an integer. Now, another question with integers. The temperature of a freezer was negative 18 degrees Celsius. The temperature outside was 30 degrees Celsius. What was the difference in temperature? All right, let us go to the board for this one. So, what's the first temperature we have? We're going to do a number line for us to just remember what these numbers represent. So 0, and then we're going to have negative 18. So negative 18, I could have drawn it this way as well, and I would have had my 0 and my negative 18 here. I think maybe you prefer that horizontal view. So let's do the horizontal view so not to have anyone confused. So this is our number line. We're just having a closer look at integers. So and we're dealing with degrees Celsius. So this is the temperature within the freezer, right? Temperature of the freezer is negative 18, and the temperature outside, now let's do a fair enough proportion. 30 is a little bit less than twice, so 30 degrees Celsius is outside. So this is the freezer, and that's outside. So what does it say now? What is the difference in temperatures? So they're trying to figure out what is this. We're trying to find this right here. So now, I'm at negative 18. How many moves would I have to make? Or how many degrees would I have to change to get to 0? If I'm at negative 18, I'm going to have to move 18 degrees up to go back to 0. So that's 18. And if I'm at 0, to make it to 30, I'm going to have to move 30 degrees as well. So the difference would be 18 plus the 30, which would be 48 degrees Celsius, is the difference from negative 18 to 30. And I put in that diagram to show you that your negative integers appear on the left, your positive integers on the right. What is the difference in temperature? You would have to move 18 degrees Celsius to get to 0. And from 0 to 30, you'd have to move 30 degrees. All right, so we have, and another way I could do it so we could also have 30. I know that some people hear the word difference and they're looking for a subtraction. So let me put it there so that the line of thought that you have still remains. So we have 30 degrees subtracting negative 18 degrees. A negative multiplied by a negative will give us a positive, and we will have 48 degrees Celsius. For those who expect to see some form of subtraction when you hear the term difference, that's how you'd work that one. So let's look at this one. Solve 8 plus 1.26 plus 0.07, subtract 2.3. This is a pretty easy, straightforward calculation. Now let's look at the operations that are involved in this question. We have addition and subtraction. Now when you are doing a math problem with more than one operation, there is a rule that we go by. We move from left to right as we operate. Addition and subtraction are interchangeable, but we always look at the one that appears first. So in this case, we're adding first. So let's look at what we'll do. So we have 8. 8.00 is still 8, but because we also have other numbers with decimal place, I've written 8.00 to represent the 8. 1.26, pay attention to how I'm lining up my numbers, and I have 0.07. Every place, my 100th place must line up, my 10th place must line up, and my 1st place must line up in order for me to ensure my calculation is correct. 6 and 7, 13. I put my 3 ones and carry my 1 group of 10 here. 1 and 2, 3, so I have 3 groups of 10. 8 and 1, 9, 1. So it's 9.33. Then they asked to subtract 2.3. And I've done the same concept. I've lined up my tenths and my hundredths place, and I've done my subtraction. 3 take away 0. I'm still remaining my 3. 3 take away 3, 0. 9 subtract 2 leaves 7. Points to note when you're doing problems like this. Pay attention to your place values and also order of operations. We work from left to right. So in this case, we add and then we subtract. What is the binary number 1101 in the decimal system? So we work in what we call the decimal system, where our number, the value of each place, is a power of 10. What is a binary system? Yes, if you said it is a number system that has, the binary speaks to base 2 system, which uses only powers of 2. I said 2 digits it uses. So it uses 1 and 0. Unlike our system, we use 9 digits. Well, actually, we use 10 digits. We use 1, we use 0 all the way to 9. And that's why it is the decimal system or the base 10 system. Now, let us look at the base 2, the binary numeral system. So let's go to the board for a minute, just to refresh your mind on how our decimal system works. So let's say, for instance, I had 3,475. This place, we all know it's our ones place. And because it is a power of 10, it is 10 raised to 0 power. And this one, 10 raised to 1 to 1, 10 raised to 2, and 10 to 3. Now, what does that mean? All right, so if we had more time, I'm just going to tell you no, that 10 raised to 0 is our ones place. Any number raised to the 0 power will give us 1. 10 to the 1 power, it's 10. 10 to the second power is 100. 10 to the third is 1,000. So you know this, that this is your ones place, this is your tens place, this is your hundreds place, and this is your thousands place. You know this. Hence why we say 3,475. So now let's look at the diagram on the screen. If I could get a close-up because the numbers are a little bit small. So the first place in the binary system, the 2, it's now power of 2. So it's 2 raised to 0. And that is still, remember what I said, any number raised to the 0 power will give us 1. So that is our ones place. Then the next would be 2 to the first power, and that is our 2. 2 raised to the second power. Now, how did I get that? I forgot to tell you. So when we're here, it's 10. It's just 10. This one is 10 to the second power, which would be 10 times 10. So the power tells you how many times you're multiplying the number by itself. So 2 raised to the second power is 2 times itself, which is 4. 2 raised to the third power is 2 times 2 times 2, which gives us 8. So now let's look at what we're looking at. I don't know if that is clear enough, so let me take it to the board and just quickly show you what I mean. So the number is 1101. The first place would be 2 to the 0 power, 2 to the first power, 2 to the second, 2 to the third. I already told you that this is your ones place. This is your 2 place. This here would be your 2 times 2, 4th, and this would be 8. So this one means 1 of 1, 1. 0, 2s, 1, 4, 1, 8, which I have over here. So now if I wanted to change it and look at what the real value is in the decimal system, our base 10 system, we'd say how many ones am I represented? How many 8s? 1. So it's 8 multiplied by 1 plus 4 multiplied by 1 plus, there's 0, 2, and then the last one would be 1 times 1. 8 times 1 is 8, plus 4 times 1 is 4, plus 0 times 2 is 0, plus 1. So we have 8 and 4, that's 12, 12 and 0 is 12, 12 and 1, it is 13, as you can see there. Next question. What is 1.6 multiplied by 609? And paying attention to how I set out my work, it is simply calculation here. We multiply. Once we are aware of how to multiply, so it's 6 times 9 is 54. Place my 4, carry my groups of 5, of my groups of 10, I should say, and you will do the calculation pretty much as it is to give you 974.4. Use your number sense. So just remember, if you are multiplying 609 by 1.6, 1 times 609 is 609. So that should be pretty much easy. And 0.6 is a little bit over half. So you should expect more than 300. So you can pretty much, by using your number sense, look if your answer is on the right track. All right, pay attention to your decimal places. Check and recheck your calculations. Okay, next question. A property sold for $1.25 million. The 4 owners receive a quarter of the money each. How much money do each receive? All right, so let's look at what it says, $1.25 million. What does that look like? How is 1.25 million written in digits? So we have 1 million and quarter of a million is 250,000. So 1.25 million is 1,250,000, as you can see clearly on the screen. Good. Now we need to share $1,250,000 into 4 equal parts. And we know what we do when we want to share. We're going to divide them into 4. Divide 4 into that amount, and we get 312,500 each. That is the share for each person. All right. The exchange rate for $1 US is 0.9 euros. So basically we have 1 US dollar is equal to 90 cents euro. A traveler has 450 euro. Convert this to US. So let's look at information before we even start in the calculation. Which is the stronger dollar here? Did you say euro? Good. Because you need all of a dollar to get 90 cents euro, right? So let's look. Euros are of more value than US. That means 1 US will give you less than 1 euro. For every 90 cents euro, you get 1 US. So how many 90 cents can we get from 450 euros? And we would divide. And when we divide, so what I did here, we multiply by 10, it gives you the same value, but it's easier to work with. And I've done it to both numbers. So I now have changed my 450 to 4,500 and my 0.9 to 9. Dividing 9 into 4,500, 500 US dollars will be equivalent, in this case, by 450 euros.